This is Knowledge Engineering with Semantic Web Technologies. And this is part 5 of the first lecture, Knowledge Engineering and the Web of Data. And in this lecture, I'm going to show you how to make use of the Web of Data and of Semantic Web Technologies. Okay, so what is the Web of Data? Of course, the Web of Data is a web of, not of documents, but of data which is here encoded in RDF, which we have learned about in the last part of the lecture. So there is the so-called linked open data cloud that you see here, which is publicly available RDF data in the web. And all this data can be identified via URIs and can be addressed or accessed via HTTP, so the standard web protocol. And the nice thing is, all these data fragments that you see here are somehow linked among each other. So, and therefore they form a huge graph or a huge cloud that you see here. And in that web right now there are about 10,000 data sets available with, you see here, more than 85 billion facts, and they are linked with more than 800 million links among each other. And in the center, at the hub of this huge cloud, what you see here in the lower left corner there is the DBpedia. So this semantic version of Wikipedia we have talked about in the last part of the lecture. If you want to know more about that web of data or learn about some statistics of it, you can click on one of the links that I have here provided in the left corner of the slide. Okay, so what's the benefit? Let's look at a specific website. So here I have the example of BBC Music. Some of you might know that website. On BBC Music, of course, this reflects the program of the BBC broadcaster. And therefore, of course, they want to display information about artists which are played in the current program. So the problem here is, of course, you always want for this artist to display, let's say, the latest publications, the newest songs, the newest discs, and you want to know where does he have an audition or something, or a concert, where was the last concert. So this is data which would constantly have be changed and maintained, and this, of course, is rather costly and complex. So for that reason, BBC now for a long time already uses publicly available linked data resources. So for example, here for the BBC Music website, BBC uses linked data sources such as, for example, the DBpedia, or for especially Music Brains, Discogs or Last.fm, which provides lots of information about music, about artists, about songs and stuff like that. So the nice thing about that is, here you can dynamically aggregate this information and display it in your website. Of course, you could do this also with traditional technology, but here you do not have to do screen scraping on these websites of Wikipedia, of Music Brains, of Last.fm. And you also don't have to use a specialized API, an application programming interface, to access the data from that site. You simply use the standard access mechanisms, which means the data is addressed via URI and it can be accessed via HTTP because all of the available data has a known URI here. So this is pretty simple. All the available data is here provided as linked data. The access works or functions via HTTP requests. And the nice thing now is you can include this data into your website, and this changes dynamically on the original website and will automatically also then be, if it's transferred to your website, displayed there without any manual maintenance, without any manual interaction and effort. And of course, this is a nice way and rather cost efficient. So this is one of the benefits of linked data, that you can use this standard API for lots of different data sources, and they all are organized in the same way, so that the access and the display of this information is rather cost efficient and rather simple. Okay, so this is one of the benefits. But the Web of Data itself also provides you benefits, for example, when you're dealing with search engines. So here in document retrieval. Document retrieval in semantic annotations means if your documents are endorsed or upgraded with semantic annotation, this is quite nice. So for example, in Google, when you are using semantic annotation with schema.org. We will learn about schema.org, which is a specialized vocabulary that you can use to put structured data, to put semantic data to your original data. And therefore, for example, if you have a shop, a web shop, for example, you can provide data about prices, data about availability, data about ratings and stuff like that to the products that you are offering on your website. And you can put this information into your website. And if it's encoded with schema.org here, for example, or with RDFA, we will learn about RDFA, then the web search engine is able to extract this data and make sense of it. And then, for example, here on the Google Shopping web portal, you are able then to filter, for example, products according to the price and to the availability and to lots of other categories that you might choose. So this, of course, is rather comfortable. But you can use this data, of course, also in a non-commercial setting. So we have already seen in the first parts of the lecture this knowledge graph, which, for example, here is available at Google, but is also used by other search engines. And here, of course, for entities which have been discovered in the query string, lots of information, of structured information, can be additionally displayed. But it cannot only be displayed. So here, for example, it's used for search recommendations that you see here in the lower part of that red box. But you can also use this information to answer questions. So question answering is another topic here. And the same search engine is also able to answer real questions. So for example, if I ask here, who was the first man on the moon, then the search engine displays the correct answer, Neil Armstrong. So you will not only get documents as a result which might contain the right answer, you will get the right answer right now. Of course, in general search engine, this approach is rather limited and more sophisticated questions are not so simply to answer. For this, there are so-called fact retrieval engines, like, for example, Wolfram Alpha, which is rather powerful in interpreting natural language questions. So here, for example, I tried the question, how far away is the moon from the Earth in kilometers? And then you see here that the search engine tries to interpret correctly the query and then gives the result correctly here in kilometers, but of course gives you some additional information. So for example, how much would this be in miles, in meters, or for example, how long would the light require to travel in vacuum from the moon to the Earth? So this is Wolfram Alpha, which is capable to answer more sophisticated questions. And these are some results from the recent tasks, and they show somehow the success of these semantic technologies, and not only semantic technologies, but from technologies which are often framed or referred to as so-called soft artificial intelligence. So we are speaking here from a so-called renaissance of soft artificial intelligence. So maybe you have known, or you know about that IBM research project called Watson. So Watson was this computer who was able to beat the human champions in this quiz game called Jeopardy, for example. And here, of course, many technologies that we are talking about now, including technologies from information retrieval and statistics and stuff like that, are involved to produce things or answers that are somehow compatible or comparable with answers of a human, and which often surpass these answers or are better answers. So the success of these so-called soft AI technologies depend on traditional information retrieval approaches, which are combined then with machine learning, knowledge mining, for example, and on the other hand, lots of statistics. So, in the end, I also want to show you where information retrieval could lead us to. So usually we have started with retrieval, which means we were looking for documents, we were looking for answers. But sometimes, searching is not always so easy because you do not have necessarily the thing what you are looking for in mind. So sometimes you want simply to browse and to know a little bit more about things. So this then is so-called data exploration. And for example, you could start here with Neil Armstrong, which was our original example when we were looking for the first man on the moon. And simply because all of these available data in the web of data form a huge graph, you could follow the links in the graph and then you could explore the knowledge that is here. So for example, you could simply see that Neil Armstrong was part of the Apollo 11 mission. And then if you are interested, of course, you can look up the other crew members, which were Michael Collins and Buzz Aldrin. So you might see that Apollo 11 was part of the Apollo program. And therefore, you might also be interested in Apollo 13, which, a special number, of course, was a rather special mission because it almost or nearly failed. And there was an interesting movie about that. So Apollo 13 is likewise also similarly in another class, which is called here Space Accidents and Incidents. And from this, you might come to the so-called Space Shuttle Challenger disaster, which might also be of interest to you. So you see here, you are following interesting paths, and these paths can be pretty diverse and can lead you to somewhere completely different, to something which you were not looking for in the origin of your search. And this then, if it's a useful thing you have discovered, if it's a serendipitous discovery, is of course a lucky finding. And this is where search and retrieval might lead us to in the future, to this kind of data exploration. Okay, and these were some of the possibilities or applications that are possible based on the web of data, based on the semantic web. In the next part of the lecture, we will start and go through the technologies that are required to enable the semantic web. And we will start with the first layer with so-called URIs and with the question how to name things.